When you're given just a graph and you're asked to come up with the piecewise function, first let's take a look at the separate parts of the graph. I'm going to call this part right there number 1, and that's the 2 and then the 3. Getting into the number 1 here, that line, I'm going to take a coordinate there. Negative 2 is right on that line, and then that point right there is, the best I can say is it's negative 1 and about 1.5. And I'm going to do the slope formula, so the y2 minus y1 over x2 minus x1. So I'm going to have the slope is the 1.5, the 1.5, take away the 2, it's going to be over the negative 1 minus the negative 2. So simplifying that slope, we get a negative 0.5, and it's just over 1, so we're going to call the slope negative 0.5. Now I'm just going to write down the y equals mx plus b form. This is the way I like to do it. And I'm going to fill in 3 out of the 4 bits of information there. I'm going to use one of my coordinates there. Let's say negative 2, 2. And in the negative 2, 2 coordinate, the y value is 2. So I'm going to plug that in for the y value in the equation there. And 2 equals, and then I'm going to put in the slope that I found, which is the negative 0.5. And then instead of writing x, right now I'm going to use the coordinate, which is the negative 2. Put that there times the slope, and then I'm solving for b, so I just put plus b. So when I solve it down to get b, I end up getting that b is equal to 1. So I've just found my y-intercept and I have the slope. So I'm going to write equation number 1 down here so I can keep track of it. It's really just y equals a negative 0.5x plus 1. And then I'm going to move on to solving for that looks like a quadratic in the middle there, the one that's number 2, the blue one. You may recognize this is a quadratic. It's a parabola, and therefore we're talking about something that's x squared. And when we're talking about something that's x squared, what the best thing to do is the easiest if we do especially because we know the vertex there, that's your vertex, and you know that coordinate is at 0, 2. And then we can use any other point on the graph. And I want to point out too that even though you can see this is an open circle, so you know that coordinate right there, that's an open circle for the blue, which would be at negative 1, 1. Even though that's not going to be able to be actually on the blue graph when we report the whole function, the piecewise function, when you list out what goes where and with which x values, you can still use it to find the equation of that quadratic, of that parabola. You can use it to find it because it's pretty easy there. Negative 1, 1 is pretty easy. I mean, I could also use this point down here, the negative 2, but I wanted to point out you can still use a point even if it's not going to be included in that function. So I'm going to use that, and I'm going to come up with an equation, and as I said, I know the vertex, I'm going to use the vertex form of a parabola. And that is the y equals a, and then parentheses x minus h squared plus k. So in the vertex form of the parabola, again, we know that the vertex of a parabola, we always call the x-coordinate of the vertex h, and the y-coordinate of the vertex we will call k. And then you can see them in the formulas here where you've got h minus h and you've got plus k. So I know h is 0 and k is 2. And my goal is I really need to find out what a is. And the value of a, the way I'm going to do that is I'm going to use a coordinate. I can just use a coordinate on this. You can't use the vertex, because if you use the vertex of 0, 2, it doesn't work. You can't use the vertex for the hk and then also plug it in to find what a is. So I needed another point, so that's why I'm using the negative 1, 1. So when I plug that in, I'm going to just say for a minute, using that point, negative 1, 1, that when y value is 1, I'm trying to find a, but when the y value is 1, I said that the x value is negative 1, so I'm going to put in negative 1 for x, and I'm going to go minus, and the h value, the vertex, was 0, so it's really just minus 0 squared. When I can simplify that too, you're really just going to have minus 1 squared, and so that's just going to be 1. So far I have 1 equals a times 1, and then plus k. Well, I said that k is the y-coordinate of the vertex, so that is a 2. So that's a 2. So subtracting the 2 on both sides, I'm going to get a negative 1 is equal to a. So now I know my a value, and I know my vertex. So I can write, this was equation 1 here, I can write equation 2. And I'm going to write it as y equals, and then the a value is a negative 1, parentheses. I really don't need to do parentheses because it's x minus 0 anyway, so I'll just write x squared. And then it's going to be plus the k value of 2. So that's my parabola. Now we're going to take a look at the third graph there, the green line, and come up with the equation for that, just like I did with the number 1 with the red line. So I'm going to find some points on there. It's a little bit unclear here, but I'm just going to go with that point is, it looks like it's about 2 and 1.8. And again, I want to point out, it's open circle, so it's not going to be included in the piecewise function, but I can still use it as a coordinate to find the equation of the line. And the other one I'm going to use clearly there is that 3, 2. Alright, so I'm going to find the slope using x2, y2, x1, y1. So I'm going to get, it's the 2 minus the 1 for the y's, 2 minus 1.8, and that's over the 3 minus the 2. So that comes out to be a slope of 0.2 over 1, so 0.2. Now I'm going to use the y equals 0.2x plus b formula there, plug in some y values, or a y value, which I'm going to use that coordinate of the 3, 2 right there again. So when y is 2, that equals, I'm going to get the slope of 0.2, and instead of x, I'm going to plug in that 3 coordinate, and then I'm going to find b. So I'm going to put plus b. So I'm going to solve for b. I'm going to do 2 equals, and the 0.2 times the 3 is 0.6 plus b. Subtracting 0.6 on that side, I'm going to get a 1.4. So now I know the y-intercept is 1.4, so I can write my third equation. Y equals 0.2x for the slope plus 1.4. So now they have the equations. Of course, now I have to figure out, when I put it in the piecewise function notation there, I have to say which equations go for which x values of the domain. Let's look at the red one. What I look for here is kind of where the two graphs meet. I'm gonna, even if they don't literally touch, what x value do they end up coming to, right, kind of heading into? What I mean is, if you look at the red there, it stops at x is -1, and the blue basically appears to kind of start around x is -1. Even though it's an open circle, it has the open circle at -1. So you see that one point, the red point, is above that blue open circle. So that means that right there at -1 for x is a key region. It's a key point where I need to distinguish that the red graph, the line, is to the left of that, and the blue graph, the parabola, is to the right of that, but I have to decide, okay, which one is actually at the value of x is -1. So what do? As I showed that that where the dotted line goes up shows that I hit that red point. Okay, and the graph, the red graph, the line, is everything to the left of that. Okay, and you can see that this is a solid dot right there. Solid dot means that that red graph line comes in and it exists at x equals -1. Okay, so x can be equal to -1 there, or anything less than that. So that means anything to the left of that or less than -1. So right down next to my equation number 1, which corresponds with that, I'll write x as anything less than or equal to the coordinate of -1. Moving on to the blue one, I want to take a look at the regions that it exists in. So we already know that it kind of starts at -1, just past it, and we can see that where it kind of meets up with the green one, again, even they don't touch, the blue one has its last coordinate at 2 for x, and then the green one has that open circle right above it at 2 for x, and so that's kind of that key barrier right there where one stops and the other takes over. So when x is 2, now I have to decide which one gets the equal sign and which one doesn't. So we've got this, that the key there is a solid dot is with that blue parabola, so I'm going to have to write that as equals. Okay, that the x coordinate, when x, so we know that it went from, the blue started right after -1 because it's an open circle. So that's why I write -1 is less than x for the blue, and I don't write equals because it wasn't equal. Then I'm going to go to, which is that x is less than or equal to where that solid blue dot is, which is at 2. So that for that middle equation there, number 2, we know that x, this exists anywhere when the x coordinate is right after -1 up to and including 2. And then now going into this last line, number 3, the green one, we know that it kind of picks up right around, right at when x is 2, and so therefore that is going to exist anything, there's an open circle, so it's going to exist right past that, right past, like x is like 2.001 or whatever, and anything forever to the right. So the way I'm going to write that in the piecewise function is I'm going to write that last third equation applies anywhere that x is greater than the value of 2. So now putting it into piecewise function piecewise function notation, I'm going to take what I've got there down in yellow and put that into the way you're supposed to write it. And notice that for all the equations, I had y equals, y equals, y equals. They're all y equals, right? So, but in the function notation, we're certainly not going to write y equals 3 times. And we're actually not even usually going to use y. What we're going to do is write f of x, which kind of stands for y. So we're going to write f of x instead of y, and then we're only going to write that once. Then I'm going to actually put the equations right inside. Those equations are going to go right inside. So I got the 0.5x plus 1. And then I've got the negative x squared. Then I've got the negative x squared plus the 2. And then I've got 0.2x plus 1.5, or 1.4. And then I just have to put where they apply. So for the first equation, that was anywhere x coordinate was less than or equal to negative 1. Then the second equation was, of course, negative 1 less than x less than or equal to 2. And then the final one was where x is greater than 2. And now you have it all in piecewise function notation. So hopefully I helped you work through those. You just have to take your time and then follow how I did that, and you'll be fine.